Hi guys, I'm here today to talk to you about properties of water. So if you will let me share my screen with you. Okay, so water is really critical for all living things. And so it's really important for you to understand some of the characteristics of water and why it's so important. So if you remember from our chemistry review, water molecules are polar molecules, polar covalent bonds. And remember, that means that the electrons tend to hang around the oxygen more than they do the hydrogen. So we get a slight negative charge on the oxygen and slight positive charges on the hydrogens. This allows for the formation of hydrogen bonds between those polar water molecules. This process, this polarity, this allows for a lot of the properties that make water so useful. So we're going to start with the idea of cohesion. And cohesion is the attraction of molecules for other molecules of the same kind. Okay? So hydrogen bonds between water molecules will hold them together. So notice in the picture here, these water molecules are sticking to each other. Well, think of it this way. If you were to grab the hand of the person next to you, and they were to grab the hand of the person behind them, and then you start running, and you're pulling them along with you, that same process happens in these plants and things like that. That's what cohesion is all about. That cohesive force basically is it's almost like they're holding hands with each other. So it allows for the transport of water and nutrients against gravity in plants. Think about some of these trees. Think about the giant redwoods that they talk about. These things are massive. How on earth would you get water from under the ground all the way up to the very top of these trees? And cohesion is one of the key factors that makes this possible. It is also responsible for surface tension. Have you ever seen those bugs that look like they can walk on water? They can do that because the cohesion of the water molecules, these things are sticking together in such a way that it's like holding it together and making it a harder surface for the bug to walk on. This is a property that allows liquids to resist external forces. And we're going to do an experiment where you're going to test some of these ideas. So the cohesion causes the water molecules to stick together, and therefore they can move up the plant from the ground to the leaves. Another property that we like is called adhesion. And the idea with adhesion is that the clinging of the molecules will cling to other molecules. So not only is the water clinging onto each other, but it's also grabbing hold of the walls. Okay. And this is also still due to polarity because we've got those slight positive and slight negative charges that can attract with each other. So in plants, water clings to itself through cohesion, but it also lets this water cling to cell walls or cell membranes, so it's resisting that downward pull of gravity. So if somebody had their hand, if everybody had their hands against the wall and then they're also linking their other hands and we start trying to pull, they're going to move slower because they have that grip against the wall that makes it easier to resist that movement. So adhesion as shown in this picture, is where we're sticking to the walls of the xylem. Okay. Then we have what we call capillary action. Upward movement of water due to the forces of cohesion, adhesion, and surface tension. So we have these abilities, but how do we get the water to move up? So what happens is that when adhesion is greater than cohesion, it basically helps it crawl up the walls. And we actually sometimes work with this teeny tiny little straw. The hole in it is even narrower than those coffee stirring straws. But the idea is we call these capillary tubes, and what will happen is you can actually get the water without any outward force. The water will climb up from bottom to top in the capillary tubes. This same process is what one of the key factors that helps water move and the nutrients with it from the ground up to the top of the trees. So to get water to the top of those redwoods, we've got to have adhesion, we've got to have cohesion, we have to have surface tension, and we have to have capillary action. It takes all of these things just to get the water all the way up there. So capillary action occurs moving water upward. Another thing we like about water is that it has a temperature control effect. So the properties of water from these hydrogen bonds that we form that are holding it together actually play a role in controlling the temperature. Water has what we call a high specific heat. It takes a lot more energy to change the temperature of water than it does to change the temperatures of other substances. Think about if you were to put a drop of alcohol on your arm versus a drop of water on your arm, and you go outside in the hot Texas sun. They're both going to evaporate pretty quickly, but which one evaporates first? So water resists changes in temperature. How does it do this, you say? It's because of those hydrogen bonds. The heat must be absorbed to break those bonds, but heat is released when the bonds form. So if we're having to put heat in to break them, but then we know that they like to form these bonds really quickly and easily, we're adding heat and losing heat. So it's going to take a whole lot more heat to break them without rebuilding them just as quickly as we break them. So that's the idea, is that we've got to, so it moderates the air temperature. Think about it. If you're near the beach or you're near the lake, the temperature variations aren't as extreme as they are in places that are further away from water sources. So large bodies of water can absorb heat in the daytime and release heat at night, and they actually keep the temperature from changing very much. It will stabilize the ocean temperatures. Wherever you travel, you find that in general, the ocean temperatures are fairly consistent at the various depths. And that's because of this temperature controlling aspect of water. So it's going to benefit any marine life because they're not going to have to deal with constant fluctuations in the temperature like we do. Organisms, which if you remember, and I know you've heard this for years and years and years, are made primarily of water, H2O, there's a lot of water in our systems, can resist changes in their own internal temperatures because of this amount of water that's resisting a change. So that's actually what helps us regulate our body temperatures. So when we go outside and it's 103, our body temperature doesn't immediately shift up to 103 really quickly. If we stay out long enough, it will gradually increase because the external temperature is so far above, but this is what actually helps us maintain our body temperatures. And then, of course, we all experience this, especially in the summer sun, evaporative cooling. Why do you sweat? Water has a high heat of vaporization. Basically the same reasoning behind that high specific heat that we had in temperature regulating. So it takes a lot of heat for it to vaporize. So molecules with the highest kinetic energy leave as a gas, the ones that are hotter. This is what we do to moderate Earth's climate. So the reality is we constantly have water evaporating and water condensing. And we'll talk about the water cycle a little later. This stabilizes the temperatures in lakes and ponds. This is why part of the reason that the temperatures in these things don't fluctuate a great deal, which once again is very good for the living organisms in the water, like the koi behind me. And it prevents terrestrial organisms from overheating. So we sweat, we go outside and we sweat, and as that liquid, the water from in our sweat evaporates off of our body, it helps cool our bodies because we're giving off a lot of that heat energy as it leaves the body. But here's the thing most people don't think about. They don't think about the fact that this actually works for plants too. It prevents the leaves from becoming too warm in the sun. And I want you to think about this. If you've been out in the sun and you walk underneath the trees, a lot of times it's a lot cooler under the tree than it is out in the direct sun. This isn't just because the trees are providing shade. A lot of this has to do with the evaporative cooling process coming from those plants. We call that process transpiration. We're going to talk about that a little later too. Okay. So then we come to the idea of ice. And if you think about it, water is one of the few substances. When water freezes, what does it do? It turns into ice and ice floats. You add ice and water to a glass, the ice floats to the top. Why is that a benefit? So as water solidifies, it expands and becomes less dense because of the hydrogen bonds. So as those bonds that are holding it together, they're going to kind of expand. When they're cooled, water molecules will move too slowly to break those bonds. So they're not going to, and that's what makes it a solid. They're not going to break. But what this process does is it actually allows marine life to survive under floating ice sheets. If ice sunk when it froze, it would drop to the bottom of the pond and we would build a layer, and where would the fish go? They would be exposed and eventually they'd freeze. But what happens, because it floats, it forms almost like an insulating protective barrier on the top of the pond. And all the living things stay underneath it, and they stay at a kind of nice, comfortable temperature for fish and other aquatic organisms. So hydrogen bonds cause water molecules to form a crystalline structure. So what does that mean? Imagine the 3D crystalline structure of ice. Think about what it's going to look like. How many hydrogen bonds can one molecule of water make with its neighboring water molecules? So start with one water molecule. How many bonds can it form with its neighbors? Hopefully you came up with 4. Okay, so when we're talking about water, a lot of times we're talking about solutions, and solutions are made up of a solvent and a solute. In terms of a solvent, water is a versatile solvent. Polar molecules are attracted to all sorts of ions and other polar molecules because it has those little teeny tiny plus and minus charges because they don't share those electrons equally. This allows for that attraction to these other charged particles, and they can start forming bonds. So we have a solution that's a homogeneous mixture of two or more substances. And when we say homogeneous, that means it looks the same throughout, so we can't see all the little particles. Kool-Aid, if you've ever mixed it totally from those little teeny tiny packets, you put water, you put the Kool-Aid powder, and you put sugar in. 3 different substances, but you mix it up, and all you see is red Kool-Aid. The solvent is the dissolving agent, so that would be our water in this case. The solute are the substances that are dissolved, the Kool-Aid and the sugar. Okay, so like dissolves like. Water can interact with sugars or proteins containing many oxygen and hydrogens. We've got to be able to get to those oxygen and hydrogens because water is oxygen and hydrogen. Like dissolves like. Water will form hydrogen bonds with sugar or protein to dissolve it because the hydrogens and oxygens in the molecules can interact with the hydrogens and oxygens in the water. Okay. Ionic compounds, because they have the partially negative oxygen and the partially positive hydrogens, are going to interact. So those partially negative oxygens in water are going to interact with the positive, excuse me, or cation, here sodium. The partially positive hydrogens will interact with the negative or anion, chloride, and it actually helps it break into pieces, which is why the salt dissolves. So it dissolves the ions. Okay, so the last step is I want you to do the concept check. So you're going to describe what would happen if you mix potassium chloride, that's KCl, with water, and that includes drawing and labeling a diagram to justify your explanation. Identify one property of water that contributes to the suitability of the environment for marine life, so what helps the marine life succeed in their areas, and then predict one disruption that would occur if in the environment if ice were more dense than water. You're going to answer those 3 things. Well, thank you for taking time to talk to me about properties of water.